Hey, it's Brandon Devnich here from Pegasaas.com. I hope you're doing well. It is Friday, March 20th, and I have gotten out of the habit, but I'm going to try to get back into it, especially with all of this social distancing that we're experiencing, to try to make some connection with you, to let you know what goes on here at Pegasaas and what we're including in our updates. So this is for version 3.1.7, and just to give you a little bit of history here, most of the updates that we have released since version 3.0 in February have been a lot of bug squashes. And, you know, that's going to happen. A lot of new features, a lot of features that have not been tested sort of in the wild. You test them on our testing environments, we run them through it, everything seems fine, but then you go and have a bunch of scenarios you hadn't even considered before. So a lot of that was bug fixes. The last three have really been about compatibility. And when I say compatibility, I mean like there's a third-party plugin and it's suddenly not working or not working as expected when Pegasaas is installed. That Pegasaas takes a very, I'm not going to say heavy-handed, but it takes control over the output of the page. And there are other plugins which also try to update the output buffer, which is what we try to capture, and sometimes that they don't play together unless we specifically engineer the system to look for their signature. Also, in other situations, a lot of stuff that we've experienced is the new, what we call the basic foundational optimizations that we're including in the plugin for non-premium optimized pages. So we give additional coverage to make the overall site as a whole faster, maybe not as fast as the premium optimizations, but it benefits the entire site. Well, that system itself hasn't gone through the testing for the last year and a half that we have had the API optimization. So we kind of have two optimization systems. We have the in-plugin optimizations, and then we have the API, which has a much deeper and richer feature set to make the pages go faster. So it's the premium core API optimizations, and then there's the on-the-fly optimizations that you typically see in other optimization plugins like lazy loading and deferral of render blocking resources, and the core stuff. We wanted to include that for the non-premium optimization pages so that you would have at least some coverage of the rest of your site. So that's where most of the either bug fixes or compatibility issues that we've been addressing since February. In the last three patches, I guess you call them, 3.1.5, 6, and today's 7, have been more about compatibility rather than necessarily bug fixes, although they're somewhat related. And so that's what I'm going to talk to you about today. So the first one is the Thrive Architect page builder. It's much like any other page builder. It's not much like. Those that love Thrive, and I'm sorry, I'm not trying to say that you're just the same as Divi or Elementor. Everybody has their strengths. But like those, there's a preview mode. And when Pegasaas was being used and there was a preview, the page wasn't rendering right. And we took a look at it, and there was a couple things going on. First of all, in Thrive works really best in a render block scenario. Render blocking, if you don't know what render blocking is, I'll explain it, because it's one of the core issues that we try to address with web performance optimization. So render blocking is before the page can render into view, the CSS and the JavaScript, which are render blocking resources, they block the rendering of the page. They must be loaded and parsed into the page. So in a render block scenario, the HTML loads, the CSS loads, a couple images start getting loaded in, and then the JavaScript loads and is parsed, and then once it reaches the fully loaded state, the page blinks in. And it can blink in, and it blinks in its final state. Okay, that's where your page load time can stretch out to 10 seconds, because sometimes the CSS takes a long time to load, and all the images, and JavaScript, all the different resources. Okay, In a non-render blocking scenario, we defer the CSS, which means that we tell it to load late, and the JavaScript. But what we do is we take a snapshot of the CSS that is required for the initial page load, and we call it the critical CSS snapshot. And we have an entire engine that is dedicated towards analyzing that for every page that we run through the API. And it injects it in the page so that the very first, all it takes is the HTML to load. The HTML loads and instantly the page loads. So whereas before it could take 10 seconds before that rendering happens with a render block scenario, we can get this to half a second, 1 second, 2 seconds, 3 seconds. And so the Thrive architect, or the Thrive builder, I should say, or Thrive themes, they work best in a render block scenario because they do some pre-calculation on the widths of some of the HTML headers and stuff like that. And it's designed so that it can work in different browsers, but again, it works best in a render block scenario. Because what happens is the HTML gets sort of built and a width is applied, and then the JavaScript kicks in the page, resets the width to how it figures it should be, and then the page renders. So you don't actually notice anything changing because it all happens behind the scenes before the page renders. So it's like you click on a link on a page to go to somebody's, you click on a link in Google, go to somebody's website, and the icon is spinning, and then boom, the page loads in. It's not because your internet is slow, it's because that page, all the resources are having to load and then it renders. Okay, in a non-render blocking scenario, you click on that link in Google and the page comes up instantly. It's because everything has been, there's a critical CSS snapshot and everything's been deferred loading till after that initial snapshot has been rendered. Okay, so what's happening basically with the Thrive system is that it has some pre-calculation and then it does the JavaScript recalculation of the page. But in a non-render block scenario, I'm coming around to it, you see the first calculation of the width of the page, and then once the JavaScript loads in just a little bit, go. And so things don't work. It didn't look quite right. We had already encountered this in the API some time ago, and so we took the code that we wrote in the API and dropped it into the plugin. Piece of cake, right? Of course, we had to analyze and go, what's going on here? The other thing that we noticed in the with the Thrive architect system, in this, actually it was just this particular system, and it wasn't necessarily Thrive that was causing the issue. It was us, in that when there are Google fonts on the page, there are multiple different plugins load 2 fonts, and another plugin loads 1 font, and the theme loads 3 fonts, and there's multiple requests to go and load the Google fonts in the system, and that takes up more resources and it's not as fast as if we bundled that request into one request to Google. Okay, and so we were doing this. However, recently we've noticed that, and this was already fixed in the API some time ago. Again, this is where we take what we learned there and drop it into the plugin. But sometimes the font request has extra parameters such as the character set or the display type. And what was happening is that when we were bundling the font families together, we were not removing certain bits of information and tagging them on to the end of the request. Lesson learned. So again, we took the code from the API, dropped it into the plugin, conditioned the code properly, and everything is perfect, okay? So that was 2 issues. The third issue, we noticed we had somebody tell us that the infinity scrolling or infinity loading, sometimes you have a bunch of posts and you say hit a button that says load more and it loads it into the bottom of the page, and then you can scroll and then you do that again. That wasn't working, and that had to do with a conflict in the basic foundational on-the-fly optimizations, where we were appending some code into the on-the-fly infinity scrolling HTML, and it just wasn't being interpreted properly. So we fixed that. And again, it was it was a one-liner fix. We just wrote an exclusion for this particular type of request. And then the final thing, and this is actually probably one of the coolest things, was we had a request from somebody that uses a provider that is cloud-based, and there's a lot of cloud-based web hosting providers, that was explaining that they were being notified that the request, they had a number of requests that were timing out at 120 seconds. Now that is extremely unusual. We have measures in the Pegasaas system to make sure that no request, when it's a heavy data handling mechanism, such as when you're loading up the Pegasaas dashboard, or it's recalculating the scores for the site, or it's clearing cache, those items can take a little bit longer. But we limit it, and we basically say, hey, okay, the scripts, the execution starts here, and if you get past 15, 20, 30 seconds, stop. And we'll do it more on the next load, just so that we don't enter into these sort of situations. So we should never reach 120 seconds. And it twigged that we had encountered this once before, probably about 6 months ago, with another cloud provider. And at that time, their support was able to determine that the cloud database system that they link into, which was a bit of a black box even to them, the database connection was timing out, but then it was not sending back a response to the PHP handling system on the server, that it had died, it had timed out. So there were two independent systems going on, and basically, what we did at that time was made sure that all of the data handling for Pegasaas, we kept it under 30 to 45 seconds. That seemed to be adequate for that hosting provider. This new hosting provider seemed to find that that was probably still too long, or at least this is what we're gleaning from the troubleshooting. So we took a look at, was there a way where we could shorten the database connection time? And so what we've included in 3.1.7 is a very experimental, and by experimental is it probably will fix this problem for different hosting providers. It might not fix it for everybody, but at the very bottom of the miscellaneous settings is something new called database refresh connection, something like that, where if you enable it, it will, if the page request takes longer than 15 seconds, it will quickly close the database connection and restart it, so it's a brand new connection to keep the database connection from being more than 15 seconds. And you can change that to 30 seconds or 45. Again, this is an experimental feature. We are not turning it on by default because you don't need to do this with all web hosts, but it is a way of just ensuring that we're not going to get a stale database connection in a cloud environment. So this is just some of the stuff that we deal with every week, and it's left field, right field, dugout. It's different every day, every week. But it helps that I haven't been just doing this for 2 years. This is almost 20 years of experience in working in these different environments, right from the command line up through databases into HTML, CSS, and JavaScript. So there's quite a bit of depth of experience with what I do. And luckily I get to apply that every day. It's actually pretty neat going, I'm gonna pull that little string out from, hey, I experienced that in 2009. Let's go and apply a fix for that now. In any case, that's what we're including this week. Thanks so much for joining me. Hope a little bit of knowledge bomb dropped on you there is helpful. If not, whatever. But there you go. So hopefully I'll try to keep up on this. I was doing this earlier on last year on a regular basis. Just finding myself with a little bit extra time here, so I thought I'd share what's in this week's update. Thanks again for joining me, and we'll talk to you again next time. All right, bye-bye.